Hey guys, Easy Science here, making science and math easy. Studying for an exam, just learning for fun. You've come to the right place. Today's topic of part 2 of calculus, the calculus series, limits. Okay, we have this set up. So, let's check what a limit could be graphically expressed as. So, let's look at the graph here. Let's say we want to go to the point 2. I'll make this more clear. Let's work with x squared. So let's say we want to zoom in on the point 3, or just check it out. So let's see, point 3. What would that be? Just put the line to where the graph goes. It looks like it's 9. So we could write this as a function. So f of x is x squared. So f of 3 be equal to 9. Okay, makes sense because 3 squared is equal to 9. Okay, so here's what a limit would look like, the formal expression of a limit. So a limit is basically a function that its input approaches a value, so does the function approach it. So let's visualize this better. So, okay, let's try writing. You could also rewrite that with like an x to the c. So yeah. So let's write x to the third to to c. C is equal to 3. Sorry for my bad writing. So what would this equal? Can't really. Well, you could solve it like this, writing that limit of x as it approaches c is equal to x squared, and do the same thing. So limit, as x approaches c would equal 3 squared, which is equal to 9. So the graph doesn't really plot a point, it more approaches it. So it's like you're having, here, let me draw this clearer. So you have like this telescope, or microscope, sorry for the bad writing. You see it's the point, it's like, that's where the point is, and it's covering it, but as you put the limit, it keeps getting smaller and smaller until it's going to the decimals, like 9.0001. That's like the average range of it, and you could like assume it's 9, but that's not necessarily what it actually is, the point. I'll give you an example right now. So before that, I'll just give an example in real life. So let's say you're walking to the supermarket. Sorry for my supermarket drawing. Right here, you have 100 meters to walk between you and the market. So if you just input your speed, so it takes you 5 seconds to get there. So you just f to 5, which will equal 100. So basically you walk 100 meters and you get to the store. Well, not really. When you're doing it with a function, finding the y value, you're basically teleporting there. So from here, that's your 0 part, start, and as you go to 1, you go here, and you keep advancing, and if you just directly go to 5, ... you'll basically teleport there. The limit works differently. Limit is as you were walking there. So instead of having you teleport there, just get there in one simple move, a limit basically takes a large move and makes it simple, or it makes it smaller. So, okay, first part, let's say instead of having it zoomed in on 100 meters, or on the 100 mark, let's pretend that's 100, it was just overall zoomed out your microscope. It looks something like this. not having any parameters, just having the whole function. That's what basically happens here. Supermarket. You go to a supermarket, it's zoomed out as much as possible. But when you start zooming in, you get smaller parameters, like this. It's basically as you've walked a bit. But it does that infinitely. So then you go even smaller, zooming in. You go smaller, smaller, and now it's 5 meters away. But you keep going until it's 1 divided by infinity almost, which equals 0. So you could assume that as you do it infinite number of times, you could assume that's the number. So in our case, like I showed you, the limit of f to the third of x squared would be 9. But that doesn't mean like 9 is the actual value. That's the general value of what you zoomed in on. So you're still approaching it. By approaching means you still have a bit to go. Like maybe it's 0, 0, 0, 1, but you're still really close to it. So you can assume that is the limit. Okay, now we have a problem here. 5x to the cubed minus 6x squared plus 2x minus 1. That is what the function is. Now let's find the limit as x approaches 1. So it's something like this. Instead of going through all the process of zooming in, you can take shortcuts, like just substituting the 1 in, like you're plotting the point, but not necessarily, because it's still a limit. So let's evaluate that. 1 cubed. So since it's 1, easy number working with, you don't really have to calculate anything. So it's going to be the same problem, both no x, minus 1. Now let's solve that. Negative 1, then plus 1 equals 0. Is 0. So the limit of h of x, sorry for my writing again, as x approaches 1, will be equal to 0. So on the graph, sorry for my graph, as you zoom in infinitely on this random graph, or here, let's make it more realistic, on it, it'll be 0, appears to be 0. So it isn't really 0, it could not be 0, but it appears to be 0. There's also the concept of discontinuity. So let's say you have the graph at 5, but, or let's say 6, but there's an empty hole, a hole in the graph. When you plot it, it's going to be undefined. So f to 6 will be undefined, but as limit approaches, so f of 6, f of x, as x approaches 6, would appear to be 4. Where the point lies as you approach it, it would be 4. But that doesn't mean it is 4. There's also many types of limits that sometimes when you plug in numbers, it's undefined. So let me show you how to still find it. So let's say this limit, that's a cube. So let's plug in 2. So it will be, I'll just calculate 2 minus 8 divided by 4 minus 4, which ultimately is 0 by 0. And I did that by direct substitution like I showed you before. So what do? Is that point not there? Precisely. So when you do direct substitution, that's what happens. Or if you try plotting it, same thing will happen. It'll equal 0 divided by 0. That means the point isn't there. So we have to approach it differently. So that would be f of x. Or, I can use that for an example. This would be f of x would be equal to g of x, which is an identical function, or has the same plot points. I'll show you what I mean by this. So one of the methods would be factoring, but there's many more methods like multiplying by the conjugate to rationalize it, or I'm not going to explain all of them because that would make the video way too long and you'll get bored most likely. So first thing to do just be to write it down for reference, but more neatly this time. Okay. Yes, sorry about that. I was trying to get a nice problem in. So, by factoring, out of here, what common numerator do we have? X squared, sorry. So, x squared, take it out, there'll be x minus 2. So if you multiply x squared by x cubed, x squared by 2, 2 minus x squared. Good? Okay. What do we have here? We apply the rule a squared minus b squared. B squared. What would that equal? That would equal a minus b multiplied by a plus b. I bet everyone heard of this. Let's do it right now. So it would be x minus, or here, what would that squared be? Let's rewrite it more neatly. Here, I'll take that away so it doesn't take too much space. So that'll be the same thing as x squared minus 2 squared. So x minus 2 multiplied by x plus 2. So what does this equal? Or what do you, well, like, probably you see that you cancel some stuff out. It's exactly what we're going to do. So let's cancel these two. So now, what does this mean? This means that g of x cannot equal anything at x equals 2. Do you know why? Because we just canceled it. If so, but that means it can't equal at x 2. Because as we approach it, you'll see that it's a blank point. We're just finding the limit, not the actual point. So that will be irrelevant to know. It's going to be undefined again. So we're left with x squared at x plus 2. Solve this, we plug the 2 in. So 4 divided by 4 equal to 1. So, which both of these limits, since they're equal, but except that x cannot equal 2. So it would equal limit of f of x as it approaches 2 is equal to 1, just like g of x as it approaches 2. Okay, so we solve for the limit. So at the graph at x equals 1, it would be, or 2, sorry, it would be a 1. It would look something like, but here, blank dot, and keep going. So there's nothing there, but as you approach it, you come to a point. You magnify on the point. Okay, there's two more things I want to talk about. First is the squeeze theorem. Squeeze. Oh. Checking if I spelt that right, because one sec. Sorry for the spelling error. So what is this? Basically, it would be. One sec. So basically, be here, like a nice graph. It would be having 3 graphs or 3 equations. First one would be something like this, or here, or like this, and then there will be f of x. We're trying to find h of x. Okay, it's undefined at that point or whatever. And we have another graph going like that too, g of x. And at h of x, it passes through that point that everyone interconnects, h of x. Basically, if that point is 3 and f of 3, so let's say limit at x approaches 3 is equal to, or will equal 3, and if they're all at the same point with h of x included, h of x would also be equal to 3. The limit h of x as x approaches 3 will equal 3 also. So basically gets squished by g of x and f of x. Okay, let's say you have a limit at infinity. At a limit at infinity, what are you thinking about, Michael? So, yeah, Michael's my name, by the way. Okay, so let's graph this. Here, I'll put the graph in. Let's check this graph out. Thank you, Desmos, for giving me the opportunity to use your graphing tool. So, the graph of this function is the limit of x approaches infinity of 4x squared minus 3x divided by x cubed. So, what are we seeing here precisely? What we're looking at as it goes to infinity. So 5, 10, 15, blah, 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 to infinity. On the graph, it's easy because you can see what it's approaching. It looks like it's getting smaller and smaller to 0. Okay, that's probably what the answer is. What if you only have the graph or the equation of it? How would you find something at infinity? I'll show you a method that I usually use. So first, find the highest degree. Highest degree is highest exponent of the function. So in this case, it's 3. So what I would do is divide by it every single term. So instead of being this, it would be 4x squared divided by x cubed minus 3x divided by x cubed divided by x cubed to x divided by x cubed. So what happens here? You know that these cancel out, so be equal to 1. But what happens here? This one, we could use the same, okay, this would be the same thing as x squared minus 3x, or x to the cubed, it should be 4x negative 1, it should be 4 divided by x. So we could just take that out, 4 divided by x, and 3x for y. Same concept, which would make it 3 divided by x squared. Okay, let's put this into account. We have 4 divided by x divided by 3, 2x divided by 1. You can just keep the 1 there for purposes that we'll see in the future. Remember that thing I showed you that 1 divided by infinity is equal to 0? Well, that's a limit too. That'll be limit as x approaches infinity. It'll be 1 divided by x. What happens here? 1 divided by 2 is equal to a half. 1 divided by 10 is equal to 1/10, which you see gets smaller and smaller. You see, add 2 zeros. Okay, let's add 2 zeros. If we had 1,000,000 zeros, we'd have 1,000,000 zeros down. So it's not going to 0, but it's very close to 0. It's approaching 0 as you go to infinity. So it keeps getting smaller, smaller, smaller to infinitesimal, and we assume it's 0. So 4 divided by x, okay, 0. 3 divided by x squared, 0. What's 0 minus 0 divided by 1? 0. So the limit as this approaches infinity is 0 as well. Or, yeah. here. Okay, so that's basically all you need to know on limits. Next video we're going to have is going to be on continuity. I'll explain that in the next video. I want to do limits first because continuity involves knowledge of limits for a bit of time. Okay, thank you for watching my video. I appreciate it. Please subscribe, and if you like the video, like it, please share it and comment. I appreciate you for watching. Look for my next uploads in a couple of days, maybe even tomorrow. See you guys.